8.5, taking it one step closer to the end of the chapter. First, we have to talk about least common multiple. So this is kind of like the same type of thing as least common factor, except we have a multiple because we don't just have just numbers. So one thing when you're doing this, you want to factor first. So this first one is 2x plus 2. That's this. And my second one would be x minus 3. X plus 2. So you want to figure out, in between these two things, what's the smallest thing that I can multiply to get. So it's really about matching them up. So when I'm looking at this, I need to have a 2 for my least common multiple. I need to have an x plus 2. I need to have an x minus 3. And I need to have an x plus 2. Well, I already have an x plus 2 here, so I do not have to write it twice. So this right here would be my least common multiple. This is the smallest number that I could multiply in order to get the least common multiple. So what about when I'm dealing with least common multiples with numbers and with variables? You can rewrite the 12 and the 18 with prime factorization. It will make it a little bit easier. So 12 is the same thing as 2 squared times 3, because that is the same thing as 4 times 3. And I have my x squared, y, and if I factor this, it would be x plus 1 times x plus 1. So I do 18. 18 is 9 times 2, which is 3 squared times 2. And I have my x, y cubed. I have x plus 4 and x plus 1. So now my least common multiple. I have 2 2's here. I have 1 2 here. So I need at least 2 2's. I have 1 3 and 2 3's. So I need at least 2 3's. I have 2x squares and 1x squared, so I need at least 2x. I have 1y and I have 3y's, so I need at least 3y's. Now I have 2x to the first right here. I only have 1 over here, so I need 2 of them. So this will be x plus 1, and I'm going to square it because I need to have 2 represented. Now this is the one that I haven't had it yet, so it will be x plus 4. Now, you could leave it like this, but it would be easier if you actually multiply 2 squared times 3 squared, which would be 4 times 9, which is 36, x squared, y cubed, x plus 1 squared, x plus 4. This is more acceptable answer. Do C, please. So now we're getting to actually adding. So you're going to have to state the restrictions just like we do with multiplying and dividing. You have to find common denominators. That's why we need to know what the least common multiple is. So first thing I'm going to do is factor. So on top here, I can't do anything with that x, can't do anything with the x minus 1. So I'm not going to. Then I have adding. On top, I can't factor anything out there. On bottom, this becomes x plus, x minus 2 and x minus 1. You want to figure out what your least common multiple is. So my least common multiple will be x minus 2 times x minus 1. So that has to be the exact same on both top and bottom. You have to find your least common multiple, your common denominator, basically. This is already the denominator here, so I don't have to change anything with my numerator for the second one. This one, I need to have an x minus 2 on both top and bottom. So in order to get that, I have to multiply. So here I would distribute. So I have x squared minus 2x. So I'm distributing the x because I need to multiply it by 1. This is again your common denominator right here. So now I can actually add them together. So on top, I'm going to have x squared minus 2x plus 2x minus 1 over x minus 2, x minus 1. At this point, you want to state any restrictions that you may have, and I do have restrictions. I have 2 of them. I have x cannot equal positive 2 because of this one right here. X cannot equal positive 1 because of this right here. Now you want to simplify. Now this is where it can kind of get long. So these 2 cancel, leaving me with x squared minus 1. You have to realize that you can factor the top. You have to know when can I factor, when I can't. So this can be factored to x plus 1. X plus 1, just kidding, x minus 1. X plus 1, x minus 1, on bottom, x minus 2, x minus 1, because you have to be able to factor to see if, oh, these two cancel each other out. So my final answer would be those two restrictions still. Those restrictions do not change. And then the final answer would be x plus 1, x minus 2. I want you to try the other two, 3 or 4. Can't remember how many there are. Yep, keep on trying those. Subtracting, it's the same thing except subtracting. There's a little added bonus with this one. So first I'm going to factor. It's always what you should do first so you can find your least common multiple. So I have an x and an x minus 2 minus, I still have this x plus 2 on top. I can take out a 2, that's a 2, leaving with x minus 2. So now my least common multiple will be an x, a 2, and x minus 2. That's what should be the same on both top and bottom. So a 2x and then x minus 2. So when I'm looking at this first one, I don't have a 2, so I need a 2 on both top and bottom here. So I have to multiply this whole thing on top by 2. So this becomes 2x plus 4. On bottom, I do not have an x, so I'm going to have to multiply both top and bottom by x. So this becomes x squared minus 2x. Now here with subtraction, well actually first let's state our restrictions. So my restrictions, x cannot equal 0 because of the x by itself. X cannot equal positive 2 because of that x minus 2 there. Now with subtraction, you should keep this as a add, change this to adding, and then you have to distribute your negative to both of your terms. So you're distributing your negative, so you're changing your sign. That's what subtraction is changing your sign. So with the orange, I'm changing my sign. So now on top, I would have a negative x squared plus 4x, because these two are like terms, plus 4 over 2x, x minus 2. You have to be able to factor. I personally don't like it when my leading coefficient is negative, so I would probably rewrite it like this. So I'm taking out that negative, changing both of my signs. So now I can factor on top. So two numbers that multiply to get negative 4, add to get negative 4. I would have this negative 1, and then x minus 2, x minus 2, and on bottom I have my 2x and x minus 2. And again, I need to do that so that I know that these two would cancel out. You only cancel one. There's only one on both top and bottom that I can cancel. So my final answer would be negative 1, x minus 2, over 2x with these two restrictions. Try the other ones by yourself. We are going to be going through them in class, FYI. And last but not least, complex fractions, meaning you have a fraction in both the numerator, so on top, and or the denominator. So this looks like a fun one. Oh, maybe we should try to do that one in class, even though it's not an example. So much fun. Don't get overwhelmed by this. So really what you're doing is you're concentrating on top, then bottom, and then together. So when I'm looking at this, I'm going to make sure that this is my division bar right there. So if I'm focusing right here first, so I'm going to have equals, that first division bar. I have to have common denominators. So I have to multiply this top one by y over y, and then this one by x over x, because that's my common denominator, xy. So this would be y plus x squared. This was where the y came from, plus x times x is x squared. On bottom, this is like 1 over 1, so my common denominator would be y. So on bottom would be y. This becomes y, so this would be 1 plus this becomes y. So first you had to combine the top, then the bottom. You now state your restrictions. Restrictions. Whenever you see a fraction, the bottom, x cannot equal 0, y cannot equal 0. That's the same bottom there. I still got my y. So now I have this division. So remember, dividing by a fraction is the same thing as multiplying by its reciprocal. So now if I look, that first fraction is going to say exactly how it is. It's not changing whatsoever. But dividing by a fraction, multiply by the reciprocal. So the reciprocal now is y over y plus 1. I'm changing to y plus 1 just because I feel like I need to. That creates a new restriction though. So now y cannot equal a negative 1. So now when I multiply across, I would have y times x squared plus y over x, y plus 1. So now I could multiply this in, so it's x squared y plus y squared. However, I'm not going to do that. And the reason why I'm not going to do that, because once I write this out, I see that these two y's can cancel. A y over y is the same thing as 1, so those cancel out. So I have x squared plus y, which cannot be broken up, and then x, and then y plus 1. So this is my final answer. You do not have to try to do any of these because I know they're difficult. We're going to do them in class. Yep, these we're going to do in class. These right here, we're going to do in class. You have a supercalifragilisticexpialidocious day today. Have that today.